So I'm Michael Jung. I'm from a company called Falk Electronics, a small company in Germany. We do RFID reader modules. And 5 years ago, we started going into the contactless payment business, providing payment modules for contactless credit cards. And today I want to talk about the payment card industry security standards. I'm not going to bore you with the actual security standards. I just wanted to make some points about how perhaps NuttX could be extended to be more useful in this domain. So the objectives here is to basically discuss with the community, with you, approaches and to get feedback for enhancing NuttX security with respect to basically storing cryptographic keys on devices in the field and make sure they are access controlled. So that the software running on the device can only do with the keys what the keys were intended for. And this also includes technology for code signing, so to make sure that the application running on the device is actually the application that you think is running on the device. And if you do something like that, you need to provide some way of SDK, software development kit. So if you ship a board into the field with NuttX as an operating system running on the board, you want to be able to run customer applications on this board. And I think this would empower NuttX as a platform for payment devices, which have hard requirements on these things from the payment card industry. But I also think that this is very relevant to IoT devices, which often lack security in their designs. Okay, what we currently build at Falk is this device, which is a contactless only reader. As you see, there's not much UI on it, it's just 4 LEDs and a buzzer. When we started 5 years ago, our original plan was to build a full-blown payment terminal with pin entry, display, a card reader for contact card and MaxSwipe cards, and a contactless interface. But we are coming, as I said, from RFID technical history, and we didn't have enough engineering power to build this complete device. So we said, okay, let's start with a contactless only reader. And actually we did hit a sweet spot with this because it's very, for our terms, it's very successful in the market. So this is a Linux-based device, has an NXP RFID reader I see in it, and it is certified as a secure card reader with these PCI. PCI stands for Payment Card Industry Security Standards. We have the EMV contactless kernel for all the major credit card brands on it, so MasterCard, Visa, Amex, Discover. We do have a tamper-responsive cryptographic key store basically on the device, so that's also a requirement from PCI that you can store keys, that those are automatically deleted when somebody tries to tamper with the device, so they have tamper meshes around the processor, which are just very small meshes of wires, and the processor, even if it's turned off, it's still battery backed. Some macros are battery backed, and you have random patterns on these wires and they are read back, and as soon as somebody drills through the cover, it detects it and deletes all the keys and before you can get to them. PKCS11 is an application programming interface to interface with HSMs, hardware security modules, which are usually used to store keys. And HSMs are available in these server rack mounted big packages and also in very small packages like this. Payment applications, so the actual applications running on this device are not developed by Falk, but this is integrated into larger systems. And the system integrators develop the applications for this device with SDK that's provided by us, which is a normal GNU toolchain-based SDK with additional Falk proprietary libraries and tools. And we do deliver these tokens here, which also have cryptographic keys, and this is basically used to sign your ELF binaries so that only customer code runs on devices that the customer bought. Yeah, it's certified to be compliant to payment industry security standards. We don't have any PIN entry, so this is not doing PIN processing, it's only protecting your card data. So sensitive data is the credit card number, your name, expiry date, because that is what you can use at Amazon to buy stuff if you capture it, right? So that's what you need to protect. And it's very much a plain Linux system with a key store and secure boot and an SDK, which is in contrast to many other terminal vendors who have their own proprietary operating systems running on it and have a very cut down, restricted development environment. So we like to call it the Raspberry Pi of payment terminals, and it's very good received. It's very, for our terms, it's very good market reception. It has very good market reception. So, but there's a huge pressure in the market, basically, to do this more cheaply, because these devices still cost about $200, and like there's Alipay and WeChat, which is coming up, which does payment without any hardware. It's just smartphone to smartphone. And the credit card brands, I think they are afraid to lose business to these companies. And they want very cheap terminals, contactless only, smartphone payments, to be competitive with Alipay and WeChat. So the question is, can something be done with microcontroller as well? And I gave this a try on my own in my free time. And I think technically it's not a problem. So just a short demo. So there's a small user interface running from NuttX, running on this NXP board. These are not real development boards. I mean, they are not meant for software development by NXP. They are normally meant to do the tuning for the RFID antenna. But they have an LPC1769 processor on it, and they have the JTAG bus available, so you can program your own firmware on it. And this is NuttX running on this controller. And from the stack point of view, there's WebSockets. That's a library that was written for Linux, used for WebSocket communications. It has a small HTTP server and a WebSocket implementation. And this is a testament for how good it is possible to basically compile standard Linux libraries for NuttX, because I only had to do a very small amount of changes and it would compile for NuttX. And then the user interface is done in JavaScript, and it's doing JSON RPC. So the user interface is running in the web browser, doing JSON RPC via the C JSON library back to NuttX running on the device. And now I can enter some amount here. Pay, enter. Oh. It seems like there's interference here for the RFID. So that's the demo effect. But it can do credit cards. And that's a pretty decent microcontroller. It's 64 kilobyte of RAM and half a megabyte of flash. So there are bigger ones that you could use for an application like this. Okay. So just a short overview over the security standards. What you need to have if you do pins in your device is the pin transaction security point of interaction certification. It's not strictly required if you have a device like ours, which only does credit card data but no pin handling. But it helps merchants. Every merchant is later on certified by the CIQSA for compliance to the card data protection standards. If you have this standard for your device, it helps to get these other standards. So requirements on such a secure card reader, you need a key store on it to store the keys, but there's typically no customer applications running on such a device. It's typically meant to be integrated with a pin pad and connected in the contact-based card reader. And these two communicate via some terminal internal network. So in your vending machine, if you go to a ticketing machine, you have the pin pad, and then you have a contact-based card reader, and you have an antenna for the contactless card. And these all communicate with each other in an internal network, and it's end-to-end encrypted between the different parts of the overall terminal. But compatibility-wise, these two need to know how to talk to each other. They need the same keys to be loaded, and then they can communicate. Then the next standard, the PCI data security standard, is basically if the payment card industry looks at the overall solution at the merchant side, basically. So you are not required to encrypt all data as long as you are in the merchant network. Let's say in your grocery store. And then you have something like a firewall in the grocery store, and you can go through the internet via virtual private network or TLS channel back to, and then to the payment service provider network. So all the encryption in this case is done between the two VPN endpoints. If you do it this way, then the complete merchant network needs to be certified to be secure. In terms of nobody can physically get to the Ethernet cables and basically eavesdrop the data that's being communicated. So that's hard to maintain for merchants, and it's not usable in this low-cost environment, because you want to sell a terminal to some, I don't know, flower store, and they don't want to have MasterCard in their store to investigate the network. What you want to do is point-to-point encryption. You want the data to be encrypted on the device and then sent through public network directly to the backend system. And if that is the case, then you don't need this PCI DSS certification anymore. However, there's a lot of different payment service providers, and they all came up with different protocols and encryption schemes. So what this really means is you need to be very flexible on this device to encrypt the data in a way that the backend system can understand. So in this case, you really need the keys in the device, and your system integrator needs to be able to run some application on this device, specifically to format the data in the format that the payment service provider can understand, and to encrypt it with the keys that the payment service provider also has access to. So this is like the gold solution, point-to-point encryption. And this is what I would like NuttX to evolve to a state where this kind of use case can be supported. So keys stored on the device and system integrators being able to run their own application code on the device. Yeah?
So there actually is a protocol for the security system that's available by one of the NuttX contributors. But it's not integrated into the base code now. But there are people, like I know Xiaomi is using that security.
Yeah, I think that's Sebastian Loquette's crypto module. I have it.
I believe parts of it are usable, in particular keyword storage that is usable.
Yeah, that's very interesting, this effort from Sebastian here.
But he's a perfectionist, so it'll be a long time or never before it. So you might want to look at his working friends.
Yeah, I had some initial looks, but yeah, I need to dig deeper on this one. So how do you store cryptographic keys, and how do you enforce access control to those keys on NuttX? So one thing would be to run an interpreter and then just provide C wrappers that do the enforcement, basically, right? Then the code running in the interpreter cannot access the keys directly, or like C code would be able to do in a flat NuttX build. So we could do that with, I think, Maker Lisp, MicroPython, or QuickJS, or some other interpreter that is available for embedded systems. In this case, the NuttX flat build would be sufficient. We don't need memory protection because the code running interpreter does not have full access to the system. The cons basically are there's considerable resource load, so you need hundreds of kilobytes for the interpreter typically, and embedded developers just love C, and not Lisp. And I think it's also already pretty constrained in a way that when you develop this device, you enforce your customers to use Python or JavaScript or Lisp, and they cannot use what they want to use. So the other idea is, of course, to use a NuttX protected build, which we have heard before today. So you have a Keystore device driver basically that provides crypto services and access control. So a typical access control means the key is in the device, but you can only encrypt with these keys on the device. You cannot decrypt because typically your device wants to encrypt data and the backend wants to decrypt. If you steal a device and you somehow manage to get an application on it, and you can use the key to decrypt data, you can decrypt all the historical data that you might have collected over it. Just as an example for access control. For the NuttX protected build approach, the keys would then be stored in NPU protected memory, somewhere in RAM, flash, or in battery-backed SRAM. As I understood, Dave, the Versi board also has battery-backed SRAM, and for key storage, probably. Or
some of the NXP chips have got key storage anyway as a separate capability.
Yeah.
So.
Okay. And then you would have a PKCS11 API or something simpler, but conceptually similar, which you would do over I/O control to get access to the key store. And then, yeah, there's Sebastian Lockhead's Crypto Manager, which might be a good plugin, good module here. But then we had this discussion already yesterday evening. How secure is the NuttX protected build really? In terms of, does it 100% separate the user space code from the kernel code? And there are some comments in the NuttX to-do file which I looked at. It says, in the current design, the kernel code calls into user space allocators to allocate user space memory. It's not quite clear to me why this is a security.
I don't think there's a security problem there because it does call into the user space memory allocator.
Okay.
It calls into it in supervisor mode.
Okay.
Oh, that's a security issue because you can put a fake
return address on it.
you can put a fake allocator there and it can call into it in supervisor mode, right?
Which can do anything.
Yeah. We used to have a hook in the normal memory allocator with a hook in it that gives you control.
Yeah, you already had a command there that said this could be fixed by dropping to user mode, like it's done for the signal handlers. Yeah, I don't know how hard it is to plug
So
this.
those are things I haven't really thought about the solutions to do.
What about external attack?
External attack?
Yeah, I mean, well, I'm assuming that you disable JTAG in the terminal.
True.
But from working on Verifo's key storage in the past, I mean, we were worried about X-ray, we were worried about all types of external methods to gain access to the keys.
Well, PCI has a very pragmatic approach to security. It's not 100% secure. They just want to achieve a cert, to make it hard to a certain level. There's no 100% protection, and you need to get through the certification. So every project where you want to bring Dutch readers into a project, they have a requirement that your device has to be PCI PTS approved. So you want to achieve PCI PTS approval, and you want to be reasonably secure, but you don't have to be like 100% secure.
Is it because the only assets you're protecting are the transactions that are on the point of sale terminal that have been encrypted with that key, as opposed to network access keys or like for duck pipe?
We do protect the back-end system keys, if that is what you're asking for. And we can also put RSA private keys into this key store and then make open up a TLS channel which is authenticated by this RSA private key in the key store. And we also have keys for code signing and to make sure that the firmware has not been tampered with or changed. But this is typically compiled into the code or burned into the ROM on the controller. It's not in this. Yeah, these are public keys. But perhaps I didn't get your question correctly.
Oh no, I just was wondering why the lack of security in PCI compliance for key management.
Can I just jump in there? So we're looking at an RMX8M board, which needs to be highly secured, and we're kind of in a learning mode about that. So we had some guys come in from an IoT security consultancy, and we've been through a lot of iterations. One of the things they said to us, and you're talking about Keystores, is that sort of the same as a secure element? Because we were talking about using NXP's A71CH which is an external secured element.
Yes, it's,
Yeah.
it's basically the same
That's
kind of
protected against X-ray. and
Yeah,
all this type of
that's,
thing,
I
isn't it?
mean, if you're really, that would be the way to go.
with a secure element.
Yeah.
Yeah, but
I
think
mean, that's a
extra-
higher level of protection. A secure element is typically common criteria, EAL 5+ certified.
The other thing that seems like really relevant, maybe to jump into that question at this point, is that there was a big conversation about security in the manufacturing part of the process and in supply chain,
Yes.
and at least the sales aspect of it is that you get these secure elements pre-programmed, the private keys never leave, so you don't need a trusted manufacturing facility wherever that might be, or supply chain, and that feels really important.
I mean, there is a lot of certification going on in our manufacturing fabs to make sure we have a key injection facility which is protected with, I don't know, all kinds of stuff. So there is a lot of overhead in producing something like that and getting it certified. It's not just the device, it's all the processes around it. Yeah. But the level, the security level, that's what I meant by pragmatic approach by the payment card industries, is lower than for a SAM, which is, or a secure element. And this is the suits fighting fighting the nerds, right? I mean, because they want to have cheap transactions. They don't. I mean, why do you still have Nextstripe transactions in the US? It's because it's cheaper. It's not secure. So they want to.
I mean, so if security is paramount,
Yes.
And you can afford the extra dollar for a secure element, then that's the right way to go because it makes it easier and it's more secure, and the chip has been designed to be secure. It has things like randomized memory and metal layers and active tamper protection and things like that. Because depending on what you're trying to protect, people will go to extraordinary lengths with cryogenically freezing the device and electron scanning microscopes and things like that.
Right. It's depending on what you are trying to protect.
Yeah. And the payment industry is prepared to accept thousands of credit cards being stolen every day. They just want to keep it to a minimum.
It's just cheaper to pay for the fraud cost than to make it 100% safe.
But I think there's a level of pragmatism in here as well, that if you take an established secure element or an established process and you adopt it, you simplify your own certification regime significantly. So if you go and you say, hey, we've got the, whatever you're calling it now, the 71 device in your device, then you immediately get a hell of a lot of paperwork that's already in place before you even start on your own certification campaign.
The problem with the secure element is, for this use case, that what the payment card industry wants to protect is the primary account number, your name, and the expiry date on your credit card. And even if you use a secure element, it will still come in over the radio. It will go through an unprotected microcontroller into the secure element, and be encrypted in the secure element, then go out back to the backend system, right? So there's still this path in the microcontroller where it is unprotected. And there's also this pragmatic approach because on the air, it's clear text. So your credit card number is transmitted in clear over the air. And they specifically state in the PCI requirements that it needs to be encrypted as soon as it gets digitized. So it's all analog in the air, but as soon as it gets digitized, it has to be protected. And I guess the idea behind this is as soon as it gets digitized, it's exposed to viruses and network attacks, remote attacks over the network, and you can spread this out to the 10,000 devices in the field and collect credit card data. Whereas if you want to catch it in the air, you have to be on place. That's the difference. Yeah.
Why don't you use another architecture where you, like service provider, identity provider, SAML usage, like in healthcare, where the information from the client is never on the device, but you get it from your identity provider, and your service provider gives you access to the services you need. And the service provider talks to the identity provider, but not to the device.
Yeah, but that's an infrastructure thing, right? You need backend systems and...
Yeah, but no problem. That's
Yeah, but that's just not how the credit card industry works. They have legacy systems from like
But maybe they have to think in other ways to address this problem.
There's 1,000 different institutions and persons who have a stake in this, and it's very, very hard to move to a different architecture.
Yeah, in healthcare we have the same problems, but we solve them by thinking another way.
Yeah, but I cannot. We as a small company cannot change how MasterCard thinks credit card payments should work, or the credit card industry thinks it should work.
You were asking for the application of common sense. I think we can discard that.
Yeah.
No, it's a dollar issue.
Well,
1970, in 1995, trying to get smart cards deployed in the United States,
Yeah.
the cost of adding $1 to each credit card that was being produced was too great that the risk of your identity or your information being stolen, they're willing to pay for that.
Right.
But risking the keys for decrypting the whole banking system is worth protecting to every end.
There was a nice article like a couple of weeks ago, but we digress a little bit. But typically what you do with credit cards is read the MaxSwipe, send the MaxSwipe data back to the back end. Now, these chip and PIN cards work differently. They have EMV data, which is a couple of hundred of bytes compared to the 80 bytes on the MaxSwipe. Now, there's a lot of back-end systems which can only handle the 80 bytes MaxSwipe data when routing the data. And for the contactless cards and for the EMV, they invented a special mode where what you get out at the end is just this 80 byte of MaxSwipe data. And there's a lot less security in this than doing the full EMV transaction. But they have this backward compatibility mode for all the backend systems which can only route MaxSwipe data, which can only process MaxSwipe data. And I think beginning of this year, PCI said it's not allowed anymore to run this MaxSwipe emulation mode. And then there were 1 or 2 big retail chains in the US who had to turn off contactless payments and Google Pay and Apple Pay because they didn't manage to update their backend systems to handle EMV data.
I think we better move on before I get.
Yeah, absolutely. Yeah, okay, so other things. There's a user work queue which apparently is executes code in kernel space, which should be executed in user space. But if I don't use it, it's not a problem.
Some of the things are just kind of warnings. This has a bad effect. Don't do it.
Yes. And then there's, as we already said, the C++ constructors that would run in kernel space instead of user space if it's the automatic initialization code that's running when the task starts. But if you don't use C++ or you don't use automatic constructors, that's not a problem.
So we should talk after the meeting. We should work some of those details, like explain the fixes for them.
Okay. So and I'm not sure if that. Okay.
But you've got a more fundamental issue, at least in the short term, that NuttX is not uber widely deployed and very, very thoroughly and well tested just by the massive deployment that it has.
Yeah.
Which means immediately you take this to any certification authority, you're going to have some discussions about, well, how has this been qualified? Who's certified this? Linux, it was an issue, believe me, it was an issue, but which is why we end up with Windows CE in preference to Linux inside a cache machine. But that's a historic issue now, which is largely gone away. But you're going to have exactly those same issues. It doesn't matter how reliable it is in the real world. The people who do the certification are going to look at this and say, you don't have enough world experience.
Yeah. But we went through the certification process, and I talked to PCI QSAs, and I even discussed this with them, and they said, well, I don't see a problem. It should be possible to get. It's very pragmatic, and actually they are lowering the security because now they want to have terminal software, payment terminal software running on an iPhone without any additional hardware. And they are going to allow this just to get the transactions.
I would like to ask a question here. This is very much related. So how does the certification bodies or things look at this when you come with something like NuttX, for example? Because here we know there are issues and we might know the code, we might know various nodes that have been written, but do they do any kind of proper audit of code, or they just trusted someone to say, no, this is good? Or how does that work?
They do look at code, so they want to see specific pieces of your code.
Yeah.
With certain person.
But
the idea is that
the application.
they assume that you are not going to cheat them. They think we are consultants and we help you build a security design, but they are well aware that they cannot review these 2.5 million lines of code to see if there is some hidden functionality.
Yeah.
So they.
I mean, when you write the code, I mean, you can answer for your code, but you're dependent on NuttX doing things which I don't expect that you will be properly reading through everything and checking everything in there.
Yes, but that is accepted. I mean, pretty much all new terminals today are based on Linux, and no single person on this planet can have a total insight into Linux, right? And it's even worse for if you use Windows, right? Actually, because then you don't even have a chance to look into it.
Yeah, that's what I'm asking. I don't understand how.
It's
It's just they just trust. Okay.
Well, yeah, we had better move on.
yeah. I'm sorry
Do
about
you
that.
have much more material we need to go through?
Just one thing, so there's these new controllers coming up which have ARM Trust Zone. ST and NXP have them, it's ARM v8M, so we don't have ARM v8 support in NuttX today, I think. And I'm not sure, I think this is memory protection unit and privilege mode on steroids, something like that, so you have a third level of execution environment. There was some discussion on mailing lists about running NuttX in Trust Zone.
Trust Zone's fully implemented. I run it on the SAM A5Ds.
You ran NuttX in a Trust Zone content? Okay.
And there are users of NuttX who have silicon vendors who have used NuttX as the primary Trust Zone controller.
So what you say is, well, as soon as ST has discovery boards out for the L5, it shouldn't be too hard to get Trust Zone, to get NuttX running in Trust Zone on these?
No. So what's the CPU?
That's an M33.
Pardon me?
An M33.
So
Oh,
there's
that's
no ARM V8s right now.
yes, these are ARM v8. Then you
Yeah,
will
we just need them on.
Okay, so the major effort will be to support ARM v8 and not Trust Zone. That's what you're saying?
I don't think the effort for the
Trust
ARM
Zone
v8 is significant.
Okay.
Trust Zone is extension on ARM-V8. So
Yes, but all the other Cortex-M CPUs that are currently being supported in NuttX are called ARM v7, and I think NuttX, as of today, does not have support for ARM v8.
yeah. M33 is the first one, I guess. With Trust Zone support.
With Trust Zone support on embedded microcontrollers.
Yeah.
But this is, and this is actually marketed as a software-based secure element. So if you do something like that, and you have a very small interface between the NuttX running in the Trust Zone and another NuttX running outside of Trust Zone or Linux or whatever.
And that was a project with a university in China.
Oh,
So they were running Linux and NuttX on an IMX6.
Yeah, that gets interesting.
but now we can have two NuttX instances running on the microcontroller, which doubles the NuttX deployment rate.
I think the V8M work is not enormous, and the trust zone that's in the M33 is like a trust zone line. It's the MPU zoning requirements are being reduced down, so it's no longer a power of 2. And there are various other things which are quite nice.
Okay.
And the strengthening between trusted and non-trusted components, there's a lot more strengthening in there. So it's a very nice architecture which, from an operating systems point of view, is something we do need to look at. It's really going to be quite handy.
I think this would be a perfect solution to store keys in Trust
well,
Zone. Yeah. Okay. So then just development kit. So how do you ship a device where the customer can install his own application? And how do you give him an SDK? So this is just probably nothing new for you. You configure NuttX in a protected mode. And I would say we have some configuration called SDK. You would have a pretty full-featured NuttX kernel for your board, for the features that your board provides. Then you do the GNU toolchain with buildroot, as you do if you use NuttX buildroot deviation. And then you just create the firmware block, the kernel block, which via device firmware update could be installed if you use that the USB as the firmware part. And then you do this NuttX export, and you copy libNuttX, which has all the supervisor call proxies in it. And you put the linker script into your SDK. And then this userspace.c, that's for the header that's on the user blob, which basically gives the NuttX kernel the entry point to the user space function where it should start. And then you can compile applications for this board. And it would be even nicer if the userspace.c was already compiled into libNuttX.a and would point to a main function so that you can use a standard C code to start it up. Okay, if you use outer tools, you can write such a config site file which sets all the compiler settings and the linker scripts and something and put this into your sysroot. And then you really can compile static libraries out of outer tools, Linux outer tools packages, if all the APIs are present, via the standard flow. So it's just a configure, host, NuttX, something, and you have to point it to your sysroot, and then it.
So I've used auto tools with NuttX. I have a site I can show you where there's how to use auto tools with NuttX.
Well, there's something in the wiki, or?
No, it's on one of my personal repositories.
Ah, okay. So I think this is from an SDK point of view, it would be nice if you can run auto tools packages and CMake packages with NuttX. Just build it outside of the normal build.
So auto tools is not too difficult.
Yeah. And then there's actually some guy who tried to bring NuttX support upstream to build-root, like in 2015. I just found some emails. There's a company, VMX something, and they have a build-root where they built a toolchain and the NuttX kernel and some root file system with build-root. And Thomas Pettersoni, the main maintainer of build-root, he was actually pretty open to including NuttX into build-root. He wrote long emails making proposal on how to improve this integration. But the guy who did this then stopped responding back in 2015. So this is a dead branch. But I think that's an interesting idea to have build-root support for NuttX. Okay, and then just for secure boot and signing applications. Normally, NuttX itself doesn't have to do anything with it because it's typically the first level bootloader which checks a signature on the NuttX binary before booting it up. But then for the applications, if you actually want to sign applications, you need to put the signature somewhere, and I think this user space header would be the right place to put a signature basically over the entry point value and the text data and read-only sections. And then when any start application is called, it could basically verify this signature. And if it doesn't match, or if it can't be verified, then just do not boot the application. That should be relatively easy to integrate. So you can compile the RSA public key into the NuttX binary either, or if you have a key store, then you also could put the RSA public key into the key store and make just NuttX use it. So this basically makes sure, I mean, there's this key store on the device, which, and as soon as an application gets onto the device, it can use the keys in the intended purpose, but by signing the application, you make sure that only the correct application gets access to the keys. Okay, and if the check fails, then the device could stay in device firmware update mode so that it can be recovered with a new application. Okay, that's it. Sorry, folks.